Yeah, well, thanks for the opportunity to speak, and thanks for showing us around. As John said, it's really, the beauty of this place is really blowing me away. So today I just want to talk about legume seed dormancy and how we can use that to develop alternative establishment techniques. So just a bit of basics about legume seed dormancy. It's a wild characteristic, or a weedy characteristic basically, that ensures that it survives variable environments, and it's basically to prevent extinction, so through drought or cropping. And most of our agricultural plants don't have dormancy. We've actually bred it out of the wild forms, because when we produce a crop, we want to be able to sow it, have it germinate reliably at high levels, and germinate rapidly. So both unintentionally and intentionally, by the way that we cultivate our crops, by sowing the seed, harvesting what's actually germinated and produced seeds, we've bred out the wild characteristic of hard seed. And there's a lot of, just some examples of peas, vetch, lupins, lentils, ryegrass. They're all things that under cultivation we've actually had them drop the seed dormancy. Ryegrass, the weed ryegrass, has very good dormancy, but our cultivated forms have no dormancy. In legumes, generally the hard seed dormancy is controlled by a single gene, and so it's either on or off. You rarely get any in-betweens. There's other reasons for having sort of variable levels of hard seed. And this picture just sort of shows my science nerdy nature, because I find it absolutely fascinating. It's, this is a picture of a legume seed. It's actually a French Serredella seed. And there's two important features on a hard seed, and that's this bit here, which is the hilum, or the belly button, where it's been attached to the mother plant, and this bit here, which is called the lens or the strophiole, and it has a cleft through the middle here. And what happens in a softening process, when it's subject to or exposed to the environment in the soil or on the soil surface, that actually opens up, and that's the first passage of water into the seed. It's actually a fantastic bit of, I'll go back, it's a fantastic bit of natural engineering. So what happens with a seed, as it dries down, the seed's quite permeable above 18%, and so moisture goes out of the seed through the seed coat. But then when it gets to about 18% moisture content, the seed coat starts to fuse together and become impermeable. And then for the seed to dry further, this organ here actually opens and closes depending on the relative humidity. So if the atmosphere is drier than the seed, it'll open up and allow moisture to come out. But then if rainfall occurs or the relative humidity goes up, it snaps shut, and it snaps shut very, very quickly. And so it's quite amazing how it can do that. And then as it dries further, losing moisture through that structure, it's sort of, the seed coat is sort of semi-permeable, so if it's exposed to moisture, it will take up a bit of moisture. So it's sort of only partially hard. And then once it gets down to about 8% moisture content, then it becomes what we call irreversibly hard. And so it will only lose moisture, but it won't gain moisture until that crack opens up. So this picture here shows, this is a soft-seeded French Serredella, that side, and that's what the seeds look like at harvest, and they're generally brown because the seed coat is being oxidised because it can't control anything moving in and out, whereas that's the hard-seed French Serredella that I bred, and at harvest the seeds are yellow and they stay that way until they actually soften or you scratch them. And then this is where I've actually artificially softened them through exposing them to fluctuating temperature, and it just shows that the water going through, I've used a stain, an iron stain, to show where the water goes in first, and it shows them going through that lens structure, whereas the soft-seeded one, the moisture just goes everywhere because the seed coat's holy, I suppose you could say. And really the ecological reasons for it is twofold. As I said, one is to be able to provide survival across seasons if you have a failed reproductive year, but also it controls when the seeds will germinate within a season. And also, I believe it's a very big factor in terms of survival through grazing. So hard seed allows a small seed to flow through a grazing animal, whereas a soft seed will get digested because it can't control its moisture content. So just an example of this. This would be frightening for conservation agriculturalists, but there is a reason for this. This is actually one of my trials where they plots, and this is actually a plot of Trifolium spumosum, or bladder clover. That's its seed head up there. You can see a different treatment here has actually got quite a lot of stubble on it. But when the farmer put the sheep into the paddock, they just sat on top of this plot and chewed up all the seed. It actually produced 800 kilograms of seed per hectare, which is pretty good yield. And when I went out there after the paddock had been grazed, I was horrified because the sheep had just sat there and licked up every single spumosum seed. And we've now found out that it's like butter to them. It's a very high nutrition, very high in energy and very high in oils. And so it's just like caviar to the sheep. So I wondered where the seed actually ended up. So I collected up some of the sheep pellets and had a look inside them. It was actually a really fascinating job underneath the microscope, picking it out. And this is what was in a square metre of sheep poo. So that's some melons, and they weren't viable. They'd been sort of destroyed. That's the Trifolium spumosum. That's a small seeded woolly ball clover. A couple of subterranean clovers, Bizarula. This is capeweed, one of the presents that you gave us, and that's yellow Serredella. But it was amazing how much bladder clover come through. But obviously the sheep are actually digesting some of them because otherwise they wouldn't chase them down the way that they do. So anyway, how does the hard seed break down? And it breaks down to fluctuations in soil temperature. If you've got relatively bare ground, in the summer, it can get up to about 70 degrees in the middle of the day and it'll cool down to about 15 degrees at night. And exposure to that bounce every day is actually what opens up that crack on the lens of the seed. It can be different for different species. So for barrel medic, Medicargo truncatula and subclover, it actually has to have very high fluctuations, like 65 degrees to 15 to give you the most rapid softening. Other species have sort of respond better with lower fluctuations, so Burr medic and Serredellas tend to be 10 to 45 degrees. And it's important to remember that, I mean, in winter you don't get that fluctuation, so basically you won't get any softening until you actually go through the next summer and autumn period. But what can interfere with this is also having large stubble loads, and that, for a conservation agricultural system, you have to really work out how you can deal with that, not having too much overburden if you want to try and have the legumes or the hard seed legumes into the system. So if you're carrying 3 or 4 tonnes of biomass, it's probably going to interfere with the hard seed breakdown process. As I said, there's an important aspect is the timing, is the release within the season, and then also how much is actually released year to year. So as John said, the Bizarula is very hard, so you can actually put in multiple crops and it'll actually persist through that. So this is just the pattern within a season and how it can vary, and how it can vary between, within a species. So the top line is Bizarula, and this is the percentage hard seed on the axis here. So how much remaining after periods of exposure, going from summer through to July. So yeah, as John said, Casbar Bizarula is very, very hard. And so you're only losing 15% of the seed every annual cycle. Compared to subclover, where it actually only has small amounts of hard seed that go from season to season. So that's why you can't push that in very hard rotation. So it only can just hang in there with the 1-to-1, but it really prefers the 2 years of pasture or 3 years of pasture and 1 year of crop. And
just a comparison within a species is that's a hard accession of bladder clover, while this one has a softer sort of response. And the shape of that curve is important because of when you get your rain. So if you get a rain quite early, you've lost a lot of your subterranean clover, and that's what we call a false break, because if you have no follow-up rain, you haven't got much seed coming back through to give you a base. Whereas if you have a slightly delayed hard seed breakdown, like with this spumosum, it's actually protected from germinating on very early rains. I just thought I'd explain how we actually develop those hard seed breakdown curves. And basically we stitch in a known number of seeds into this mesh pockets. That's what we call Flywire. It's a fiberglass covered in plastic. So in each of the pockets here that are numbered, we put 100 or 200 seeds that we know go in there. And then we expose them with a slight amount of soil cover and extract pockets to do a germination test at the various intervals that we want. And we may actually do that for something like 5 years to get the full picture of how the release from dormancy occurs. But on the other side of hard seededness, it enables to have persistence through cropping rotations, but it is a barrier to cultivation as well. When you want to sow it or introduce a plant, you have to break that dormancy artificially because it hasn't been exposed to the same conditions that it does out in the field. And we do that by, it's not a very good picture, I apologise. We do that by passing it through an abrasive surface. So this is a Scarifier, where that's a spinning disc. That goes on top of it. Of course, you usually have about a 2 mil gap between those abrasive surfaces, and the seed travels through there, and in the process the seed gets scratched so that the water can actually go in through that impermeable seed coat. It actually works quite well, but it's another process. But it does create a problem if you're trying to deal with the plants that I deal with, which is Serredella, and some other species as well, where the seed's actually tightly bound up in a woody pod. And it's very hard to extract that seed out of those woody pods without damaging the seed. So that actually made me think of how we could try and avoid that processing step. So how can we use something that's 90% or 95% dormant without going through that processing step? And this is where summer sowing comes in. So the process of summer sowing is you have a nursery paddock so that you produce your own seed or Serredella pod. You leave it in the dormant state, store it in a silo. It's not going to change germination much at all. And so you go into the paddock after you've harvested your cereals or canola, and in the wheat stubbles you sow in either your Serredella pod, or as we found, bladder clover can also work. So you sow that with a long-lived inoculant in January. Then it's exposed to that fluctuating temperature over the summer and autumn period, or the autumn period in particular. That gives you your hard seed breakdown, and the plants come up when you get your opening rains. And because of that natural hard seed breakdown, even if you do get some early rain, you're still going to have more seed drop out of dormancy to be able to stay there for any, when it does rain, if you don't have any follow-up, if you lose some of those plants. But in fact, a seed that's had its hard seed broken down naturally is much more robust in the system than a seed that's scarified. So if you put scarified seed in here, if you put scarified seed in here, it's probably not going to survive. So this is just some pictures to show the results that we've had. This is at a place called Minginoo, which is about a 300 millimetre rainfall zone. We sowed this plot with French Serredella pod in mid-February, and And then we were comparing it against normal sowing or doing nothing. And we got the opportunity to do a normal sowing with scarified seed after knockdown herbicide had been applied to control the weeds on the 2nd of June. And so while we're sowing this, we've already actually got quite a lot of food on the table for the sheep already. And then if we look 14th of July, so the middle of winter, and we've already got quite a lot of biomass produced when you wouldn't even be able to graze that with sheep yet. Going further, this is in late September, so towards the end of the growing season, and you can see the summer sowing plot has got, it actually had about 6 to 7 tonnes of dry matter on there. It wasn't grazed because it was in a cropping paddock. But this is what happens if you did nothing, and that's the result. It's just the weeds going crazy, the cape weed. There's double G's in there, another present from you guys. And you wouldn't actually be able to, what we would call, you wouldn't be able to run a black snake on that, and it's not very good, and all you're doing is producing weed seeds. Whereas both of those plots have had the same management. So that hasn't had a herbicide on it, that's just pure competition on controlling the weeds. And that, if you look at the nitrogen input in that, if you're looking at 7 tonnes of biomass at 3% nitrogen, that's actually putting a lot of benefit into your farming system. And I've just put this photo in. This is from one of my colleagues, Belinda Hackney, and she's in New South Wales, so a couple of thousand kilometres east of where I work, and she's in a temperate climate rather than a Mediterranean climate. And it's to show that actually the concept of summer sowing is working in a different environment and actually working better. And it's actually working with more species than what we get to work. So that's a plot of summer sown Prima. So Prima unscarified, put in February, and that's Bizarula summer sown, put in February, and that's actually a normal sowing. So that's how people would normally try and introduce their pasture legumes. And it's just that difference in getting the seeds into the ground while everything is warm. But it's easy to go wrong, as with everything, and so there are some golden rules of how to get success. And one of those is getting your sowing time right. You've got to do it early enough to allow that hard seed to break down. It has to be the right species and cultivar to give you the right hard seed breakdown curve to make it successful. Paddock selection is very important. The sowing rate has to be quite high because you've got to allow for probably a few more losses, a bit more inefficiency, and also you don't get complete breakdown of the hard seed. And it's really suited to on-farm seed or pod production because you're using higher rates and you want to keep your costs down as low. So people in WA are actually buying pod to do this, but to get the best benefit out of it, you really need to produce your own pod in a nursery paddock. The reason why the timing is right, as I said, is you've got to get it in so that you give it time to have that hard seed breakdown occur. So this is an experiment I did where I put the pods in the ground in mid-February, mid-March, mid-April and mid-May. And these are the number of seedlings, the percentage of seedlings I put in, or the percentage of seeds that ended up as seedlings that I put into the ground from the February sowing, the March sowing, April sowing and then the May. And that's just showing you that at the extreme end, the seeds haven't gone anywhere, they're still there, but they're still dormant. And it just shows that it doesn't work. So you've got to get it in the February-March period to be able to get enough plants in there for the system to work. And it works very well with Margarita, but that's where you have to get the right cultivar. So these are 2 yellow Serredellas. It's an experimental line and a commercial cultivar, Santorini. And this technique just doesn't work with Santorini. It just doesn't have the right hard seed behaviour. Whereas with this experimental line, it actually works quite well. So what we've found so far in our environment anyway, in the Western Australian environment, what works is Margarita and Erica hard-seeded French Serredella. You've got to remember that French Serredellas normally are soft-seeded, and so not suitable for this system. It's got to be the hard-seeded versions of French Serredella. In terms of a yellow Serredella, is a cultivar called Avila, which probably suits about a 400, 450 and greater rainfall zone. Bartolo bladder clover, and I'm pretty sure that arrowleaf, Cephalou arrowleaf clover, and probably some of the Burmetics may well suit it. So it could be like with Peter's system where he's actually harvesting pod. You could keep it not processed and actually put the pods out in summer and have it establish off of the natural breakdown. But that needs some more work. In terms of paddock selection, you have to have it reasonably clean. At the sowing rates that we suggest, you're going to get somewhere between 150 and 400 plants per square metre. If it's coming out of something like a pasture paddock, you're going to have thousands of plants that are going to compete against. So it's got to be reasonably clean. So it's best after 1 or 2 crops. And it does do very well after if you've cut hay, because that's given you a good weed control in the previous year. As John showed, you've really got to have no residues of herbicides in the system, particularly sulfonyl ureas or chlorpyrrolid. Where farmers have tried this technique and failed and we go out there, it's generally because they've got herbicide residual issues. And if it's an acid sandy soil, it needs to be the Serredellas. On the better quality soils, bladder clover actually works quite well. And just to reinforce that thing, no sulfonyl ureas. And just in terms of harvesting, these aerial seeded species are quite easy to harvest with an open front header. You have to have a finger tine reel. It doesn't work with a bat reel because it just doesn't drag it in. You need the fingers to be able to drag it in. It can be a bit nerve-wracking because the front ends up pretty low, so you're better off actually using a contractor rather than your own new one. Or buy a cheap old second-hand header to do it, because sometimes you have a few rocks go through and stuff. The other thing is you can use lifting fingers to try and lift it up, but sometimes if you're not paying attention, that sort of thing happens. And I was there when the farmer did that, and there was a lot of swearing going on. Another way of doing it is to use a rake and push the stubble into windrows, and that, even with things that actually shed the pods, the stubble usually will drag the pods into that windrow, and then you can use a pickup front or a canola pickup front to put it through the header. Again, you don't want to use your very best header. And that's it. Thank you very much.